podcast presentation, we are fortunate to have two speakers who are both experienced IT professionals in their respective organizations. The first is Crowdstrike Solution Architect Lead, Mr. Valerian Rossigneux. He has over 12 years of functional experience with providing a wide range of enterprise security and technology consulting services to clients in the Asian region. As a seasoned risk practitioner, he knows the information security threat vectors and understands how they operate. This has enabled him to design and deploy effective information security strategies and controls to finally stop breaches. We also have Mr. Kelvin Cheung, Senior Regional Security Consultant ASEAN at Imperva. He is responsible for security consultancy services and designing architecture for application and data security within the IT environment. He works extensively with large enterprises, particularly within the FSI and government, to secure their critical assets.
You've heard it before. The connected age. Life at the speed of the internet. It's a digital world. What you might not have heard is that we can keep it safe, because at CrowdStrike, we stop breaches. So wherever you go, go with confidence. Anywhere. Welcome to Anywhere. CrowdStrike. We stop breaches.
Hello, everybody. This is a real pleasure to be with you today to talk about our favorite topic, cybersecurity. And more particularly, we're going to go into how we can secure the cyber norm that we're living in. The agenda for today is as follows. First of all, to solve a problem, we got to define the problem. So let's look at defining what's the cyber norm today. And then we'll deep dive into how to secure cloud, because everybody is moving to the cloud and adversaries are doing the same. And finally, we'll look at some recommendations on how to protect identities, because identities are always at the heart of all the breaches. So let's dig in, defining the cyber norm. So on our side, on the consumer side, on the company side, the way we're working has tremendously changed. We're working from anywhere, from home, from airport, from a car, from a Starbucks, literally everywhere. The second thing that we're seeing is the world is moving toward a hybrid cloud. Private cloud and public cloud are heavily leveraged today. And finally, any and every company are undergoing a digital transformation today. So these aspects of our life are actually changing the threat landscape, changing the way we consume IT. And the adversaries have understood that. On their side, it is somewhat similar, right? The geographic boundaries are non-existent for adversaries, for hackers. They can strike from absolutely anywhere. Every country in the world today has some form of cyber weapons, right? Or groups that are operating from these countries for different intent. So what we are seeing at our level, companies are working from home and expanding to all the countries. It is extremely similar for hackers. What we are also seeing is, in the past, public threats and private threats were somewhat different, right? The actors were different. The tool set, the tradecraft, the techniques were quite different. The sophistication was higher for public compared to private. Today, it is actually kind of merging into one. The same groups are attacking both. The level of sophistication is sort of blending in the middle. So we're seeing a trend of collaboration between hackers, right? They are just hiring other hackers or malware development labs and so on and so forth. So it's harder to sort of like distinguish the threat actors that are targeting private sector or public sector. The other key insight I wanted to bring to you today as well is it's never been so easy to launch an attack. For a couple of $100, you can go to the dark web and you can buy cyber weapons. You can buy valid credentials. You can buy RDP login. You can buy direct accesses to already compromised machines. You can even hire what we call gunfires, right? You can hire a hacker to compromise a particular organization. This is available for a couple $100 or $1,000 in the dark web, in these hackers communities and forums. So the entry bar to actually commit attacks is extremely low today. That's why we're seeing this increase in attacks across the globe. Usually, there are two types of groups that we try to sort of distinguish. There is e-crime, cybercrime actors, extremely opportunistic. What they want is make money out of the crimes, right? They want to compromise your endpoints. They want to plant a ransomware. They want to do crypto mining. They want to do extortion. They want to steal your data to sell it. So they're financially motivated. And their tactics and techniques are very different from state-sponsored actors. These are more purposeful, right? Methodical. They are sort of like doing attacks that are way more complex. Supply chain attacks, for example, or when they are exploiting trusted relationships. This is a type of attacks that state-sponsored actors are actually doing. They want to stay low and slow, under the radar in your organization as long as possible and slowly exfiltrate some form of secrets so that they can take advantage of these things. But really different methodology and way to tackle these two types of groups. So what I'm going to present now is some of the insights that we have seen. So at Crowdstrike, we perform threat hunting across all our customer database, right? So we hunt for adversaries day and night, 24/7. And in the last year, from July 2020 to July 2021, we sort of analyzed all the intrusion that we have uncovered or we have notified the customers of. And what we can say today is we potentially stopped 65,000 intrusions. And by intrusion, I mean we saw a hacker hands on keyboard doing some stuff on the endpoints, trying to move laterally, but something live and human, not an automated attack, not a spear phishing, not a script kiddie, but an advanced adversary at play in the environment. 65,000 intrusion potentially blocked is one intrusion every 8 minutes. So imagine the pace, right, of attacks that you are undergoing. The other key trend is 2/3 of these intrusions didn't involve malware. They were entirely non-malware based, which means that if you are only focusing your security investments on detecting and preventing malware, you will be blind to 2/3 of the attacks that are seen across the globe. They are using PowerShell, they are using SSH, they are using RDP, they are using whatever tool is available on the endpoint. They will use these tools because it's extremely hard to detect tools that are also used by your administrators. They're moving away from malware and moving into what we call living off the land, right? Using tools that are already available or legitimate tools to perpetrate their attacks. The other area that we have uncovered is the pace and the increase of attacks is going up. So the number of attacks is increasing, and we have seen a 60% increase year over year. And this is, a trend that we are seeing for the last sort of 10 years, right? The entry bar is so low for new attackers to come to the market, right? That everybody wants to jump in. The gains that you can get from ransomware campaign is so high when we look at big game hunting, these groups that are, specifically crafting ransomware or ransomware campaign, the amount of money they can make from extortion and from ransoming companies, it's tremendous. So a huge spike into attacks that is continuing across the globe. The average time it takes for e-crime to compromise one of your computer and to move to your company's critical server or assets is 1 hour and 32 minutes. So imagine that for a second. 1 hour and 32 minutes to move laterally to your crown jewels. If your technology today doesn't allow you within seconds, to surface things that are suspicious, or if you cannot query your environment for, what are the users doing when they're connecting to a particular server, what are the processes they're running, then it's impossible to stop the threats. They are way too fast to be stopped. So you got to be equipped with skill set to hunt, as well as technology that gives you this insight of what is happening in your environment. One of the reasons that 1 hour and 32 minutes is the average breakout time is a lot of hackers have access to what we call access brokers, which means that they don't even need to do the initial compromise. They purchase it. They go on some of the hackers forum and they directly get access to already compromised machines. And from there, they can actually do their hands-on keyboard activities, right? They drop in the machine, they try to escalate privileges, they try to move laterally, they try to expand, plan persistence, and so on and so forth. But the fact that there is so many access brokers that are available make their job easier. The other trend that we are seeing is some of these groups, 1/3 actually, are doing their initial compromise to lateral movement in under 30 minutes. So imagine that, right? It's crazy. It's 30 minutes, they land on an endpoint, they sort of scan where they want to go, and they move to another server and potentially take the data and exfiltrate it. 30 minutes, or plant a ransomware or crypto mining software. Imagine the pace of these attackers. So you got to have that in mind when you're preparing your defense. From a pure state-sponsor actors perspective, there are some key trends that I wanted to highlight today. So you can see on the left-hand side of these slides, what are the usual suspects, right? From what countries we are seeing state-sponsored actor operating. And one of the trends of the last year is the use of Microsoft Exchange Server vulnerabilities. So because Exchange is, very common in all organizations and has some CVEs, a lot of actors have pivoted into exploiting the vulnerabilities with a lot of success. Another key trend and key learning is these groups literally have, an extremely thorough development cycle for their malware. They're running a business, right? Like you and I, right? They have a company, making malware. They are updating their malware. When we can access their malware sort of chain, right, we can see the change log. We can see that some of these groups, they update their malware on a bi-weekly basis, right? They have a change log, they have a versioning system, they have a QA, they have performance teams. So they have literally, a very agile team to develop new malware, new capabilities, new way of, logging your keystrokes or taking screenshots of your desktop, or enable your mic to record your audio or whatsoever. So it's quite interesting to know that, right? It's important to know your adversary and how sophisticated they are. From a pure vertical perspective, so e-crime is a bit like opportunistic, right? They have a wide spread across all verticals. And you can see technology, manufacturing, professional services, financial, and retail are, the top 5. But usually it's smash and grab, right? They try to find victims, they plan some ransomware, some crypto mining, or do some extortion, and they try to monetize it as fast as possible. On the state sponsor actor side, it's a little different. So the 3 sort of verticals that we are seeing surfacing at the top is telecommunication, and by far the most attacked vertical across the globe. And the other 2, which might not be a surprise for you, is academic and healthcare. And this is driven by COVID-19, right? There's a lot of research going on. There's a lot of trade secrets and strategies and processes going around to sort of solve that pandemic. Hence, the attackers and the hackers are extremely active to target these particular industries. The tools that are using, here you can see a list, right? Some of the top tools that are used by hackers. And probably, some of these names are not familiar to you, but the key thing to pick up here is most of these tools, like 70% of these tools, are not malware. OpenSSH, Procton, PSExec, Advanced IP Scanner. These are not malware. These are absolutely legitimate tools. Some developed by Microsoft, some signed by Microsoft, and they are abused, right? Abused by attackers. But the difficulty is your administrators are using the same tools. So how do you distinguish an attacker leveraging these tools from a legit user leveraging these tools? So this is why threat hunting has become so important today, to sort of have experts that have seen thousands of variants of these attacks and can pinpoint the attacker, right? Can sort of like find a needle in the haystack. So now, to close that sort of window into adversaries, I wanted to give 3 examples of some of the techniques that are quite unique to adversaries these days. The first one is, has been observed in a small academic company. And what makes it unique is the adversary was using spear phishing, but was enticing the victims to sort of use Chrome extensions. And these extensions were obviously malicious and were giving the attacker accesses to the endpoints. But what makes it unique is Chrome extensions are quite hard to detect, right? From a defense perspective, anything run within the context of the browser is not trivial to detect. But through some hunting, through some behavioral analysis and machine learning, you can actually uncover that Chrome is behaving in a weird way, or Firefox or IE, when such an extension is being installed. But it's quite an interesting, finding. Attackers are always trying to find this weak spot, right? This particular area of security that might not be covered by technology. The second example is for a large financial institution. In that particular case, what was interesting is the attacker didn't even need to perform the initial access, right? Didn't even need to come up with a super complex CVE exploitation or vulnerability exploitation. They actually had stolen credential that they found for RDP logins, which means that they could connect to RDP machines in the customer environment, bypassing any perimeter sort of detection and prevention. And this is extremely hard to detect because it's still a legit user, it's still an RDP, which is allowed in that organization. So how do you want to detect it with technology, in an automatic fashion? So again, threat hunting has been extremely powerful to detect these kind of things. The final example is at a mid-sized telecom organization. And I'm re-emphasizing here the use of native OS capabilities. So once the attacker has access to the machine, they will not, use any malware to download further tools that they have. They will use native tools that are available. Think of PowerShell, Python, Perl, wget, curl. All these tools can be abused to download further further malware, further attack tools that the attacker has crafted for their victim. So I thought that these 3 examples can give you a clear understanding of the techniques, tactics, and how advanced threat actors are today. So moving on, I want to talk about cloud a little bit, because there are a lot of challenges around securing the cloud. Everybody is moving into the cloud, whether it's private cloud or public cloud, and the attackers have understood that, and they are after you in your cloud. And this is because there are a number of misconceptions, right? The first one is a lot of people believe that if I migrate my application to the cloud, this will be more secure somehow. AWS, Azure, GCP, Alibaba, Red Hat will actually secure my data. But this is actually a very big misconception. Your data and your runtime security is your responsibility. So that is an important misconception that we need to have in mind. You are responsible for the security of your data and the security of your runtime. When you run a container, when you run a virtual machine in the cloud, it is your responsibility to secure that. The provider, the cloud provider, will not secure that automatically for you. And this misconception also comes from the fact that we don't really know, what's running in the cloud. So let's take, for example, an e-commerce website, right? So you are running an e-commerce website or any kind of service, but for the sake of clarity, I'm taking an e-commerce website here. So the first thing that people believe is to run a website is going to be pretty easy, right? We have a database and a web server, and that's it, a few resources. So the first reality is to run services at scale today, where millions of users are consuming the service that you have. It requires usually a multi-cloud approach. It requires virtual machines, containers, Kubernetes. It requires developers to be able to push code. It requires maybe private cloud as well in the mix. So it's a pretty complex environment to sort of run any service today. The second aspect that is also sort of like forgotten is this is not static, right? It's not 1,000 servers that are running, and that's it. They will not change. They will not evolve. The reality is it's constantly moving. It is growing, it is shrinking. Code is being pushed in production, as we speak, on a regular basis. Servers are being spin down, spin up. It's just so dynamic that it's very hard to keep track of what's running right now. And if you don't know what's running right now, it is impossible for you to secure it. So the first key recommendation that I would have for anybody in the call when you're migrating to the cloud or developing cloud native application or services is visibility. You cannot protect what you don't know. So having visibility on all your virtual machines, all your storage, all your containers, all your pods is absolutely critical. Without that, it's impossible to secure what you don't know. The second recommendation I would have is make sure you have security built in your CI/CD pipeline. Imagine if you can scan your containers or your application for vulnerabilities, for malware, for drift before they even hit production. So you don't even introduce some form of risk because you take that, you shift left and you do that analysis before it's hitting production. So you will never introduce these sort of like risks or vulnerabilities because you have done that, upstream. So this is the second recommendation. Make sure, you're scanning your images, your container images. Make sure you're doing that sort of CI/CD hygiene to make sure that you're not introducing issues. Even with visibility and with making sure that, you're not shipping, bad code or vulnerabilities to your production, attackers, are smart. They will still try to compromise you. One way they will try to compromise you is by attacking the cloud itself. What I mean by that is they will try to find misconfigurations in your API, in your key management, in your, your storage, allow lists, your access controls. So in order to sort of strengthen the environment, what everybody should do is some posture management, right? Cloud security posture management. Identify gaps in the cloud and fix them. If you know that this storage, this S3 bucket is open to internet, then let's fix it right away. One click, fix it, that's it. If you find that there are key management, right, there are keys somewhere in places where they should not, just remove them, right? Tighten your users, tighten your identities in the cloud. So what attacker might also do is attack your runtime. When your container is running or when your virtual machine is running, there is this span of time where it's potentially open to the attacker, right? It might be a very short time, right? Maybe your containers are running for a few hours, but it's enough, right, to be compromised usually and potentially to move laterally or do some other stuff. So the other key recommendation here is to protect runtime. So runtime protection, whether it's a container, whether it's Kubernetes, whether it's a virtual machine on Windows, on Linux, anything, right? Protect your runtime so that it makes sure that when it's spinned up, it is protected at all time. The final portion is ensure that you have hunting extending to cloud environments. A lot of organizations, whether they have in-house hunting capabilities or outsourced, sometimes forget about hunting in the cloud. Because again, there is this misconception that the cloud is highly secure. So make sure when you sort of like pick, a managed service for your security or for your hunting, that this extends to the cloud. They will hunt on attackers in the cloud as well. Because again, and I'm repeating myself a little bit here, but attackers are heavily moving to the cloud because they go where the gaps are. Now, let's move on to the other aspect, identity. 80% of breaches today involve some form of compromised identities. 80%. So imagine if you can actually tighten the identities in your environment, how stronger your environment will be against breaches. One of the reasons that this is happening is because the traditional way of securing environment or consuming IT has dramatically changed. In the past, we had offices, branches, and we had perimeter security. So we had, proxy, IPS, firewall, and so on and so forth, protecting the environment. And we were behind this fortress, right? These walls, and we had some form of security or sense of security at least. But nowadays, we have to migrate to the cloud, private cloud, public cloud. The way we work has changed. There are a lot of mobile workers, and of course, pandemics has changed that a bit, but it will resume. A lot of people are working from home or working from, coffee places or whatsoever. So the model is more like this today. Servers, workloads can be anywhere. Users can be anywhere. So the perimeter that we know has disintegrated completely. And what we're seeing is the new perimeter is workload and identity. If you can control workloads, whether it's an endpoint, a workstation, a server, virtual or physical, and if you can control the identity, then you have both, right? You can ensure that this machine is healthy, doesn't have any threat, and the user using that machine is who they are claiming they are. There is no rogue user impersonating that particular, identity. It is the person it should be. And the first thing to accomplish the identity portion is, again, visibility. What are the identities in the environment? In identity store in the cloud, so there is a lot of federation as a service, identity as a service that you're using today. There is your on-prem domain controllers, your active directories that are holding most of the identities. So the first critical component and recommendation that I have is get visibility on this. What are the services accounts? What are the stale accounts? What are the privileged accounts? What are the attack paths? For example, if someone is compromising myself, Val, can they actually move to an admin credential through my identity? If I have a clear understanding of all of these things, then I can actually plan some form of mitigation, remediation, or strategic bolstering to fix these issues that I have in the environment. So again, visibility is absolutely key. Despite visibility, the attacker will still try to come in, right? They will try to come in the organization and they will try to move laterally. They will try to compromise the main controller. Usually it's one of the key elements that they try to go after because then from there they can just launch any attack. So what is important is for you to be able to detect advanced identity-based attacks. And you might have heard some, of these attacks types: Kerber roasting, pass the hash, golden ticket, ransomware spread, RDP to domain controllers. All these attacks, can be modelized, can actually be detected through sniffing through all the authentications. So if you have a way to actually sniff through the authentications, then you can actually build models to see, oh, there is a pass the hash technique being used at the moment, or there is a Kerber roasting or whatsoever. The other portion and a recommendation I have is implement conditional access. So we are in, the early days of zero trust. So if you can ensure that there is conditional access in your environment, that will make it so segmented and so hard for attackers to move from one segment to another that they will not be able to move around. They will not be able to compromise anything because of that segmentation. For example, if I can say any administrator can only access a server through RDP if their risk level, their identity risk level is above 8, then I'll make it so stronger. And this is dynamic, right? I can actually, if that user is compromised, its risk level will go down. And if they try to go RDP to one of the server, they will be prevented. There are many ways to do that, but conditional access is a key to success in zero trust and successfully segmenting identities and segmenting the way data or services are accessed. A successful way of implementing conditional access is by leveraging two-factor authentication, multi-factor authentication. Imagine that I have a doubt, right? There is a user accessing a particular service with a risk score that is maybe average. I have a little doubts, right? So trust doesn't have to exclude control. What if I can just simply submit a MFA challenge to the user and make sure that this is the user that it's claiming and it's not a rogue users? So these are the kind of things that you can implement. And if you can do two-factor authentication whenever you have some form of doubts, then it's going to be impossible to compromise the environment, because the attacker will not have a hold of the phone where the challenge is being sent, or the Google Authenticator app registered for that particular identity or user. So these are successful strategies that can be implemented to protect identities. So now, how do we put that together, right? And what we are seeing as a successful strategy at Crowdstrike. If you can have, this is our word, right? If you can have what we call the security cloud, if you have a data lake where you can aggregate processes that are being run, files and configuration, identities and assets and so on and so forth, then you can apply any sort of processing to that. Machine learning, behavioral analysis, hunting on identities, on workloads, on endpoints, on servers and clouds, wherever the data is. Then you have a chance to stop attackers. So the quality of data is extremely important, and the ability to sort of like traverse the data at scale is the way to succeed against adversaries. On that, I would like to thank you all for your attention today, and feel free to reach out to Crowdstrike if you have any question or any follow-up requests, and we will be happy to answer you. Thank you.
Cloud services bring speed, agility, scalability, and savings. So many services, so much choice. But choice is having a big impact on security complexity. How do you ensure your data is secure in these new environments? Imperva, the industry's first comprehensive data security solution for any cloud environment. From one unified platform, protecting your business's data. Speed up your adoption of the cloud with clear database visibility. Thousands of our customers trust Imperva to protect their data in the cloud. We're here to help at imperva.com.
Hello, everyone, and welcome to these sessions. My name is Kelvin. I'm the security consultant in Imperva. I'm based in Hong Kong. I have been in Imperva over 5 years. And today I would like to talk to you about Imperva, our data security solutions. Let me give a bit background to Imperva. Imperva is an internationally recognized cybersecurity leader championing the fight to secure the data application wherever they reside. We build the world's first and only multi-cloud platform to protect the edge, apps, and database. We have been named as leaders for 3 times this year in Forest DDoS mitigation solution report. And also we are the 7 times leader in the Gartner Magic Quadrant for WAF. Now, all Imperva our portal fit into our Sonnet platform, which is a recent strategy acquisitions we made last year. This enables us to secure all the workloads, the data anywhere, and also gains more value from each product individual. For example, our WAF, API security, advanced bot protection, RAS, and also the data securities. It allows us to do things like behavior analytics, automate, orchestrate, respond to instance, enrich for insight, and store report on data is available online for years. And provide a multiple year low cost information retention periods. We are going back to archive. Today, we are not going to do all of this, but we will focus on one aspect, which is protecting the data. The Imperva platform provide you the visibility, analytics, and automates need to perform proactive response to compliance and security objectives. This is definitely not a good strategy. So to keep pace with the database activity explosions, they have been accompanied recent rapid technology innovations. You must rethink your strategies to securing the data access. Meeting compliance requirements not enough. You must develop a new approaches, which is enable complete visibility into your entire data estates to achieve the real data security today and in the futures. I would like to start with a SolarWinds hack case. The one that we have heard about so much lately, the one that we have been dubbed as the largest hack in history, and then one that we have all heard about, and then we maybe all be dealing with. And I think that this is a great example of something that is probably happening all the time and is a bit overlooked. I'm not going to drill down a bit into what happened here. And I just really think that we really can improve on, and what we can see is that it wasn't an exception. It's just another classic case. It shows that the hacker is simply in our systems. So even today, we don't know that how many still infect as a result of this hack. But my point is that no matter how good the security measure you take, the hacker are able to come in and they are most unidentifiable. It's very, very difficult to find them when they are in your systems. There's nowhere around it. So where could we assume is that if we can put good security measures with the best security product, will be very security oriented. But and then the hacker won't find their way, right? But the fact is that they will find their way in, and because there are so many ways they can be coming in and they were just in there, just in your systems. So no matter what security measures was, no matter how security oriented they was, the first step is to actually protect data, because at the end of the day, the hacker will be trying to access the data. So if the hacker in our systems, how can we actually detect this on time, right? How can we find them before we do the damage? How can we identify they are there and remove them before they're able to corrupt our data or steal our data or do whatever they want to? So this is really what I want to go over in this session. And then we had talked about why hackers are so difficult to detect, why you should protect the data as the first step, and why the data-centric analytics approach is the right approach to text. And then we will show this by some real example that things that we were able to find in our customer sites that really couldn't have been found with any other approach. This is not the data, because that is not the data-centric analysis approaches. Okay, so let's talk about a bit why hackers are so difficult to detect. Once hacker in our system, they in our internal system, right? And then finding a breach with their internal network is very complicated because there are a lot of traffic going on, running from site to site. There are tons of service, tons of user, and generally speaking, the traffic is legitimate. by somewhere behind the skin, right? There may be something phishing going on. It's very, very difficult to detect, and add to that is the fact is the hacker today, they do not strike right away. They can just stay there for months, and they will move very, very slowly and carefully. So they don't trigger any alarm. So within this system, where we have our employee, there are a lot of legitimate service who are doing the things they are supposed to do from time to time, change what they are doing. For example, we add a new employee, right? A new service, somebody doing something different than it did yesterday. So within all these data and all these things going on, we need to identify a very small behaviors that seems the our norm. They are problematic, they are risky, and then this is a very difficult task. Okay, so let's drill down into data-centric analysis approach now, and then we establish the hacker difficult to find and you should protect your data. The data-centric approach start with being data-centric. This is a part of the protecting your data breach happen in the intersection between the user and data. So we have users who are trying to steal data, right? At the end of the day, the hacker going or trying to access data. So on top of that, we had the analytic portions. There is so much going on. There's so much activity, and it changes all the time. There are so many different behavior, and which is legitimate in their system, and you need a machine which is can be analyze the data and run the learning algorithm, and then learn the typical behavior, correlate all these activities to do something very smart and very sophisticated in order to find breach and risky behaviors. But these two things are not enough. It's not enough to focus on data. It's not enough to run analytic on that. This is what you had, what you have with us. But actually, you need to add the domain expert to that. The domain expert is the part that take all this information. It doesn't fit what is out of norm. It's fit with the risky. So if you affect just what out of norms, just a general statistics model and say that this has never happened before, and this is something that we are never seen in a system, and then you had tons of false positive, because you know that every day, every hour, every minute, and something new is happening in the systems. So the next, we are going to see some real life example, which is where this is our approach actually find breach within company that we protect. It really this the case that example how this could be find only with this approach, because no other approach be really able to pinpoint such behavior that we just so they are identify this is a hacker. This is something bad in the environments. Okay, so let's start with the user case that hacker was able to gain full access to several databases with the sensitive information. And in this case, we had a hacker who was very slow, who wanted to do at this phase just to see that if he can access some of the database in the system. So the hacker knew that if they're trying to access the database but fail to log in too many times to the same database, it's probably going to rise effect. So what they did is they take for example, 3 username password, and then maybe 2 is a default username password, which is usually used if they haven't been replaced, and then 1 username password, they may be able to steal it from the organizations. So they just went to the database and say, hey, we tried these 3 passwords, and then we only have 3 login activity only, right? So no more failed login will raise will raise the effect. So 3 failed login is something that could happen, right? Anytime somebody forget their password, they just try 3 different passwords. So they just went to the first database and try with the username password, fail, no problem, and just wait a couple of minutes, and then they try to do low and slow, and then they went to the second database, trying the username password, doesn't matter, and they just keep trying slowly and very carefully. And then eventually they are able at the end of the day, they just to log in access to, we are talking about 7 databases out of these 78 databases. So kind of the sophisticated test. So if we can catch them at this point, before they had done any damage, you just find out that they just access to those databases. They don't have still any information yet. They don't know because they don't know what is inside the database yet. So they just gain that access. And then what our solution able to do was to correlate all this activity and then identify something phishing is going on here. And then we just the same source, and then we try to access 78 different databases on the relative short period of time. So we can see that on this slide, right? So we say that the interactive user, they attempt to access an abnormal high number of different database, which was 78 databases here over a short period of time. We're talking about 12 hours, which is not very short, but enough to raise a Fed. So this is really so how we focus on the database, because at the end of the day, the hacker are going to try to access that. We ran sophisticated analyze, we correlate a lot of things together here. And then for example, we say that this is an interactive user. We're trying to access different database all over the system, and then we are looking at very wide here, and then we add this to the domain experts. All of this together bring in the fact that we can really raise a critical alarm that actually allow our customer to identify that his network was infected, and then it can allow them to remove the hacker from the network. So this is the example. The first one, and we'll show you how this approach we can assist you. Okay. So the second example was the hacker. They were searching the sensitive information, and they trying to see that if they can access to it. So it's a bit similar to the first one, right? The hacker at first, they don't start to stealing information. They just check what they can access or not. They again not raise any facts, not to be any suspicious. And then many of the tools of this hacker do, they just run query against the tables. And then they make sure that the query will not return result. They do not want to query the return result because they know that if they query the return with 0 result, they will not raise a fact, or it will not be deemed themselves suspicious. So what the hacker did in this case is trying to run a query against a few databases, a few tables. So they were just to see that whether they can run the query, and then they just run the select but no result, and then what our system were able to identify was that it is a suspicious application data access. So that's what the interactive user, a human user, they're trying to direct query tables that they hold the sensitive application contents and all of this information here. Interactive user direct access to application tables on this database, and then we have identified that user then use interactive tools that came from our application servers. So a bit phishing. So in the table you can see here their names here, which is hold the sensitive application contents with 0 records. And then so even through the no record was written out of this, this was identified as a suspicion by the system itself. Again, data centers. We focus on data, the hacker that going to get their analytics, everything here is identified, so it's automatically without need any supervised by humans. The fact is that the user is interactive. The fact is that you can see that on this slide, the fact is that they are using an interactive tools. The fact is that it's their service, it's application service. If the table, they hold the sensitive information or they correlate together, we have seen that something phishing is happening here. And the customers are actually able to identify this as a hack, and then again, remove the hacker from their network before they have done any damage on their networks. Okay, so this is the only way we do efficiently respond. So we are nearly the end. So I just like to reiterate a few points here. The leverage, the loss you had already had to the breaches. You probably collect access log to the system. You probably collecting access log to your data. If you are not doing that yet, they just show that probably you need to do that. We have product for this as well, but once you have these logs, allow another system to make sense of them and get the help of the system, they can analyze them, and then it can actually produce finding out of this log because of the data is here. So you just need to leverage. It's just like a machine learning, right? And then the expertise will figure out the right from the wrong, and this is a very complicated task to figure out the right from the wrong. And then configuration of rules, of course, cannot cover all the cases. So the last point here is that a lot of our customers, they talk to us about the need to automate response, but they want to automatic respond where something happened, but they actually a big problem with automated response. Because if you are automated responding to a false positive, then you are stopping the business, and then you are doing it often or not on a regular space. This is actually a very risk to business itself. So for automated response, you need accuracy detections, and then you need a data-centric approach, and this is real combine everything together and allow customers who use it to build automation response on top of using our system or other systems. Okay, so to sum up, the hackers are inside. This is just the fact of life, no way to around it. Unfortunately, we still should be trying to stop them from coming inside, but we cannot assume that it always works. And then we see that as the SolarWinds hack is an example. So eventually they will access the data and then trying to access data. So we just protect the data. So amount of data you have to analyze is huge, and then the hacker is very sophisticated. You need a system which is sophisticated enough and more than that in order to stop that. And then the answer is analyze, combined with the domain expert system that can help you to figure out the right from wrong in a very, very accuracy manner. Okay, so this is the end of my sessions. Thank you very much.